The first one is question 38. It's a chapter 5. And that's the one about the elementary row operations and determinants. The question says that you're given a matrix. You're given a matrix A, 3 times 3, where the entries are just labeled with the first 9 letters of the alphabet. And you know that the determinant of this matrix is 5, if I'm not mistaken. That's the setting. What the question then goes to say is that find the determinant of the matrix like so. Actually, there are a few parts in that question. I'm not going to address all of the parts. I chose only 2 parts of that question. One of the parts was about this matrix A1. The other part was about this matrix A3. Well, honestly, there's more writing in this question than thinking, but still there is some thinking involved. It's all about the elementary row operations. For instance, for the matrix A1, I can argue like so. I can first suggest the following elementary row operation, the following row reduction. I can add the third row to the second one, which will take my matrix to the matrix A2 like so. If you add the third row to the second one, that will cancel this negative g, this negative h, and this negative I. And this I has nothing to do with the complex imaginary unit. I hope you understand. And then if I suggest another row reduction, like so, that will bring A2 to the matrix A. After making these 2 suggestions, I claim that determinant of A, which is given to us, B5, it is the same as the determinant of A2, because row reduction doesn't change determinants, and it is the same as determinant A1, because row reduction doesn't change determinants. That's all there is to the solution to this part of the question 38. Now, if I want to treat this matrix, I will suggest row swap. You have to be careful with the row swaps. You have to remember that every row swap, it gives you the change in sign of the determinant. So you have to be careful how many row swaps you're using. So I'd like to convert this matrix A3 down to matrix A, original one, and that will change. That will require some rearrangement of rows, and you have to do it with the row swaps alone. No shifts, no circling through the rows, just the swaps. So if I take the swap R1 and R3, that will bring the ABC row to the first position. And if I suggest another row swap of the second and the third row, that will bring the GEF row to the second position. 2 row swaps effectively means that the determinant is identical. So now I can argue that the original determinant of A is 5. It is given to us. It is negative determinant of A4 because it's 1 row swap away. And it's again determinant of A3 because it's 2 row swaps away. It is an interesting observation that actually you can probably achieve the same effect. I mean, it's the same effect like here. GEF in the first position, GH high in the second one, and ABC in the third one, by a different combination of row swaps. It is an interesting fact that even though you can come up with a different combination of row swaps, the sign still will be the same.